hi.
Hi, hello.
How
Hello,
are you
everyone.
doing today?
I'm good. I'm good. Good. Thank you
We
for
are
asking. It's early here in Chicago, but that's okay.
we
Yeah,
are
I'm all
super
excited. So,
wonderful. We are super glad to see you at Devoxx. Which time are you at Devoxx?
the time, you mean the time
Uh,
where I am
and
now, or
no, I mean, how many times have you been to Devoxx
oh,
already?
how many times? I'm sorry. This is my third time. So yeah,
Wow.
and yeah. So I always had a lot of fun the past 2 years. That was so much fun. Yeah. So I'm kind of all excited again to be back again. Yeah.
Yeah,
So yeah,
we are
yeah.
honored to have you once again at Devoxx.
Thank
And
you.
yeah, and the stage is yours. You can start your talk.
Thank you. Thank you very much. Yeah. Okay. Let me make sure everybody, you can see my screen, right? Yeah. So, okay. So I'm going to be looking over there because my screen, oh, good. Thank you. Now I can see it too on my own here. So welcome everybody to my talk. The title of my talk is called Thirst-Quenching Streams for the Reactive Mind. I mean, as such too, I'm going to be talking a lot too about reactive. I'm hoping too, if there's some time available towards the end. And because when I first submitted this talk, that time too, I was developing another talk, was actually more on using Vertex to deploy it to Kubernetes and actually OpenShift on the cloud. So I think it may be helpful or interesting to some of you. So if I have time, I'm going to also show that. But otherwise, too, I'm going to start my conversation. And again, my name is Mary Gryleski. I think some of you already have been here. And so thank you for coming to my talk. Because I think at the same time, we have two other speakers. They are wonderful, too. So thank you for being here. Okay. And okay, so let me also begin a bit of giving you some basic starter information because maybe not everybody has come here with experience working with Reactive. Although I think there are a few speakers here also been talking about Reactive. So it's just to make sure we have a common beginning. So let me also say some of these basic concepts. So forgive me if I'm repeating something that you already know. As such, too, for reactive, there are, broadly speaking, I think, the way it is going, especially when reactive is applied in the Java context. Now, also, too, before that is that this isn't like React JS, which is JavaScript, or React Native, which is JavaScript with mobile. This is about Java. And also, too, I mean, as such, it also then any kind of JVM languages, and this also apply. So kind of, they are all languages are still trying to accomplish the same thing. It's basically having systems and applications and programs that are highly responsive. And they also carry this asynchronous nature, event-driven type of nature. And also then it leads to basically there's reactive programming. So programming is essentially the part of your system in which you are working with the more like the mechanical part of it, right? So you're programming, and it's basically reactive programming is utilizing the functional style. And especially since Java 8, functional style is being supported, so functional programming is there, is ripe. So Java started having the reactive support too since then. And then there's also reactive systems, which actually is a bit of a next level up. You're not only dealing with a component is being written in a reactive fashion, but we're talking about system as a whole. They are all loosely coupled, and they are all communicating with one another through messaging. And then I'm going to just quickly talk about the Reactive Manifesto, which is like the guidelines that guide and define what a reactive system should be. And then there's also these specifications, a standard that's being worked on and first being proposed to by several companies. And now it's actually becoming a standard, Reactive Streams. Reactive Streams currently is being managed, in some ways like managed, kind of loosely managed, but it is an open source, open standard, is underneath the Reactive Foundation. And some of you, I'm sure a lot of you know Oleg Dokuka in your country, who I had the honor of co-presenting with him many times. And so he's actually representing the Reactive Foundations too, and they are actually primarily managing the Reactive Streams, helping to define it, the standards and everything. So that's also like based on like Java 9 Flowable. Okay, without further ado, let me go a bit in just to give a bit of a refresher. So this is about reactive programming. I'm borrowing this idea from the Reactive Extension, using marble diagram to describe it, because as such too, reactive programming is a bit of a newer concept, and it's not as kind of intuitive as for most of us. But when you think about it, reactive is not new, and actually reactive mimics what human beings do things, right? When we do things, we don't wait. When we do something, we kind of go do it, and then we will be, not waiting for something to come back. For example, right? And for now, let me kind of give an example. You go to the store, and then you get hungry. Go into the shopping mall. You are hungry, and you went to go order some food. But in the meantime, you order your food. The order is being processed, but you go off and do some shopping. And then you may be carrying like a beeper that will notify you, and kind of usually they vibrate or something, then you know your food is ready. So in a computing sense, it's the same kind of concept. That's what we're trying to achieve. So anyway, RX marble diagram is a good way to describe some fundamentals of streams processing, essentially. So we're talking about streams, and the top one here is an open-ended stream. There are no events. And then the second one is a stream with some events, and there's also a perpendicular line, meaning that the stream has a definite time ending to it too. And then the third one is a scenario in which the streams encounter some problem, and the problem is that there's an event that actually is an error event. And the bottom one is basically an open-ended stream, so it's basically is there and it's waiting for events to be admitted by the source. That's what it is. So, and let's take a little look. Maybe if you come to my last year, I believe I did this talk, but I want to kind of a refresher too, if you're not too familiar with it. So when we do programming using RX Java 1, the operator observable. So this is like an operator. You basically have your streams coming in, and observable.just is in your data from your stream. And then you apply a transformer, what we call like operator in the reactive Java sense. It's operator called map. Map will transform it. So it's functional style. So you basically are giving it a function for what to do with the data. In this case, a very simple case will be multiplied by 10. And then immediately too, then your client consumer for this data, you also like subscribe to it. So that's a very reactive Java way. And this actually is reactive RX Java. This one observable is the RX Java 1, which doesn't have back pressure support. But this is just an example to illustrate. RX Java 2 uses a flowable, and is equivalent of an observable, but with back pressure support. So that's that. So now if you run this, then what you will see is the output where you see that 1 becomes 10, 2 is the 20, and 3 becomes 30. And if you want, there's rxmarbles.com where you can visit, and there will be lots of examples for you to try interactively too. So that's a quick introduction. Now then, there's also the Reactive Manifesto. This is a standard, or kind of more like a specification that's began and led by Lightband, company that produced or invented Scala by Dr. Martin Odersky, and then Akka, the framework. If you're familiar with Akka too, that's a reactive framework. So the Lightband helped to define this manifesto, led this effort. And so basically, for any reactive systems, they must meet like 4 criteria, 4 principles. So one is responsiveness. Responsive, meaning the system has to be very capable of responding to all requests on time in a very timely manner. I'm sorry. And so that's basically, it's kind of really fundamental is that. And then the next thing would be I'd say the scalability part, which is elastic. So now, normally, if we're doing something simple, it's no big deal. You can be responsive. However, in reality, especially in cases such as IoT, Internet of Things type of application, maybe machine learning. You will be dealing with a lot of data, big data kind of scenario. Then basically you have so many requests coming in, so many events carrying so many pieces of data. Your system needs to be able to scale accordingly and becoming really elastic. So that's the elastic side of things. It's basically the overall thing is that your performance won't suffer. Your performance will still kind of be the same. You won't kind of suffer in terms of being able to respond. Now, in modern infrastructure, a lot of times too is that elasticity also is being. So let me continue then with Reactive Manifesto, the 4 principles. So I talk about responsive. Then we go back to talking about elastic, which I just talked about being systems very able to grow and when there are more processes, and then lower, kind of like the number of processes being very elastic. So then performance is not degraded, right? So that's the goal. And then there's also the resiliency part, meaning that if there are any error condition, then your system needs to also be able to respond quickly to this scenario and kind of bounce back, right? Essentially, it's being able to recover in a very timely manner. And then all these 3 are capable of doing so because of a very message-driven type of systems. So, and also a note too about message-driven is that it's not exactly the same as event-driven. Message-driven to me too, so it's about basically point-to-point, like with 2 known addresses. You know the sender sending something to the recipient, it knows the address. However, for event-driven is that it's in fact event-driven. It's about like mostly, if you implement it, it's like a publish subscribe type of scenario. So events are being emitted, right? Emitted by the source, but it doesn't know where exactly it's going to. It's basically up to the consumer side, right? The receiving consumer side. They need to subscribe to it. So in a RX Java way, it's basically observable and then doing a subscribe, or flowable doing a subscribe. So that's that. And okay, and let me go to the next slide. And okay. So that's the thing, is that fundamentally the kind of problems like reactive programming is trying to solve are really concurrency. So concurrency is like dealing with multiple tasks all at once. Now that concurrency doesn't require your hardware to have multiple, say, processing. Fundamentally, concurrency can be done in a software way. And basically, it can be like on the software side in which you manages all of these processes. Now, one note about reactive programming, I've also been asked to by previous some audience was saying that, well, why, reactive? You can have other ways of doing things. Let's say right now with the cloud infrastructure, you can actually have hardware clustering all of these things that's like handle all of the concurrency. But why reactive? Now that's the thing. It used to be, right? Hardware used to be simpler. There was like no multi-core machines or no multi CPU. So then you basically then on the software side, then we have to deal with the threading ourselves because the thread was being handled in the kernel level. So as such, right, it's always like one CPU, like one main thread. So you can imagine too the thread, if you are doing something else, then you have to manage like synchronizing your different multi-threading activities. So you can see that the concurrency is being achieved by that. And we all know, I mean, threading, it can be a challenge as a programming, but in a real kind of real life scenario, it can become quite messy, right? You don't know because it involves like the time element in processing all your data that comes in maybe from multiple sources and things like that. So that's concurrency. Now, the thing is with reactive programming is that it takes advantage of our more sophisticated hardware now. There are multi-CPUs machine, multi-core machines, and all of these virtualization, containerization, clustering, all of these is basically we're taking advantage of these hardware advances, and also reactive programming still are dealing with threads, but the threads are being moved into user space. So user mode threading versus like kernel mode. So that's the idea. Reactive libraries are actually basically having threads in the user mode side. So in that case, then you do not hold up the main thread in your kernel side, which actually, then it will kind of involve a lot more I/O on the kernel level. So that's what it is. So Now, parallelism is slightly different too. Parallel is also doing multiple tasks, but the idea is that you can do it all at once. And parallelism, parallel processing, does require you having like hardware. For example, multi-core hardware, multi-CPU. So, okay, and let me then move to the next one. This one too, maybe my colleague here, Grace, had spoken about it. We kind of think this is a great diagram just to show, in reactive systems too, we're dealing with, a new level of computing. So then we have different like design patterns. And these are like the more common design patterns that are being like used in a reactive systems. So first and foremost too, actually, I should say back pressure. Back pressure essentially is what reactive streams, like the main kind of target to kind of having that specifications is to handle back pressure. It's meaning that, you have a system, you can have many requests coming in. And if it's not being handled correctly, then a back pressure built up. And so that's like a very kind of fundamental pattern that all like reactive systems should have. And so in this case, back pressure will occur if you're expecting a lot of data kind of can be flooding your system. So. And then there's also, going back, there's also a circuit breaking, let's say. Circuit breaking, now, if you're familiar with physics and, of all the electronics, then the idea is the same. So if there are error that occurs, you want to kind of break that problem and then handle it accordingly, like break it, and then before you kind of reintegrating this particular component back into your whole system. So that's circuit breaking. That's also a common kind of design pattern in reactive systems. And then there's also event sourcing and CQRS, and very often we talk about them together too. So event sourcing is essentially what we're trying to do accomplish is that instead of storing the state, of your data into the database, for example, we're actually storing the events. So the events will kind of contain information about the data and the state. So in this case, is that rather than storing the data, that particular state, at a certain time, we're kind of storing it in multiple, state that their time. It's kind of like a time sequence. You store that data and its state at at that particular time. So in this case too, what you can do is that if you need to look back or kind of look back, kind of trace what's going on, you can always do a playback, with event sourcing. And then there's also CQRS, which is like separating the read and the write in your processing too. So basically it stands for command query responsibility segregation. So in this case too, you kind of like make both processes not like being like overly overbearing. If you say you're doing read and write together, then you always kind of could run into some issue. Now, this kind of CQRS is primarily to address the concurrency or kind of like a redundant, the data being not a data integrity type of problem. So if you separate them, then you have a better way of managing both your read and write. So. Okay, so now then let me get to I talk about the title of this talk, like reactive streams and streams. And streams, to me, it's been kind of quite confusing because now when we talk about stream, a lot of times too, if you kind of are working with streams programming and if people ask you what you do, you say, okay, I program and then I do streams programming. People, if they are not familiar with it, they may immediately think of, you're watching like movie, right? So it is very true. Even now, as I'm doing presentation, this is a live stream. So as you can see, stream describes like the mode of how your data is, how it flows. So in reactive programming, being very asynchronous and event-driven, that's kind of the mode of data is being kind of the movement of it, and that's what is being done is basically using streams to kind of like handle the processing part. Now, with streams processing, then we have to be aware in the reactive style of programming, there are like this two models, fundamental models. They're called push and versus pull. So push is basically also called in RX Java term, they call it hot observable. So what it is that hot is because the source of the data, it's, when it is there, it gets kind of pushed downstream. So it's a bit more like hot, it's more proactive kind of way of doing things. Like if data comes, you push it downstream, whoever is subscribing to it. But then with pull, it's the opposite. It's like whoever needs it, it's like cold observable. So the data won't move until somebody needs it. So it's sort of like code in that sense. So basically downstream would then pulls data from upstream because it needs it. So in programming terms, right, observable, this would be doing a dot subscribe. So that signals like, I'm pulling the data. But the thing is, with reactive streams, very often we describe it more like a pull than push because it's a dot subscribe. So once you subscribe to it, you signal a pull, and the pull then essentially it's when you do it, let's say a subscribe, you're actually subscribing to data that hasn't happened yet. It will happen in the future. So this is kind of like working like with Java's in Java application, then it's dealing with the futures and completable, all of these things. So anyway, so that's the idea. You can have pull then push, and that's mostly how the reactive streams are handling the streams modeling part. Okay, and oh, sorry. Let me then also just a quick diagram to describe too. So push is basically here, your producer, and the producer needs to will be emitting data. And so basically you already have a consumer being there, then it basically sends it, it sends the data without actually being asked explicitly. It's a hot observable type of situation. And then pull will be like for downstream initiate the request, the need for it, for the data, then it pulls from the upstream. But it's actually, we call it like pull. It can't really be really the one pulling because the consumer doesn't have control over the data. It's really up to then once it's being pulled, you're doing a dot subscribe, you basically subscribe to a future. And so if the future object is ready with the data, then basically the producer will then emit the data and essentially then sends it to whoever subscribes to it. So, okay. And so now some diagram to describe again back pressure. So it's like too many requests coming in, and then it's basically the pressure build up and it's kind of like turned back because you have too much pressure, and on the processing side it can't handle it. Then basically the pressure kind of reverse itself, and that's why it's called like back pressure. And this is also a diagram too, which I saw was kind of a good way to describe, in a back pressure scenario in a publish and subscribe event driven kind of case is that the publisher generates more data than subscriber wants. So that's what happened. And this is like a closer look into the reactive streams now. Now, earlier I talked about reactive systems. So now let's focus, kind of think of it like we're focusing a bit more into a specification, which is reactive streams. So reactive streams essentially, now don't be fooled by it. It looks like a simple specification. It's actually just all interfaces, and there are 4 interfaces and no implementation. And that's essentially the reactive streams specification. But it is actually managing something quite complex, as we all know. It's basically dealing with concurrency. So the 4 interfaces, it's actually not that easy to implement. Now, that's not something that we would be telling application folks, maybe a lot of your applications dealing, you're really building like end user applications or some applications that are useful for some end user purpose, right? So in that case, it's not actually recommended for anybody to use the reactive streams interfaces directly. Again, it's because of how complex it is. So there are actually popular libraries out there that supports reactive streams, which I'll be talking in a second. But these are like the 4 essentially the 4 interfaces. So let's take a closer look. A bit more is the reactive streams is essentially Java 9 the Flow API. And basically these are the Java interfaces. So if you take a look into it, there's publisher, then subscriber. Subscriber has on subscribe, on next, on error, on complete. And then there's also subscription. Now, this is the part where back pressure support will happen in there. Subscription essentially is a bit more abstract. It's basically subscription, you basically implement it at the time when there's a known relationship between, a publisher and a subscriber. So in other words, the subscriber will be there. Once you subscribe, then it forms that subscription. So the back pressure support will happen there because then, it's basically the library will kind of look at it and know that, you need to apply back pressure support on that level. And then there's also processor that basically that signals, kind of tells, how do you process the streams. So, Okay, so now then let me quickly then turn focus to the more of the reactive streams. And again, I just talk about this is the API. You follow the package org.reactive streams API, and it's specifications only and no implementations, and not recommended for us to use it, user, of the reactive systems way directly. And basically, too, these are then the more popular libraries that implement reactive streams are listed here. And so all of these vendors, they need to run through the TCK, which is the testing compatibility kit, in order to certify, kind of like a certification, right? They have to pass the TCK in order to certify that they support, they're eligible, they're capable, or kind of label as reactive streams compliant. And the nice thing about this, having a standard, just like any other standards for any other problems that we're trying to solve, is that we're promoting like true interoperability amongst them. So here's something I like to challenge you to. I know I kind of talk a lot, but the idea is that, well, sometimes we speakers come here and talk, and there's no way we can describe a very complex subject area in just 45 minutes, right? Like this. But the idea I'm hoping you will kind of come away with will be kind of start to think of creative ways. How can you make use of the reactive way of doing things? And I would like to say that, and there's also a talk that I'm going to be doing and developing a prototype, is to see how can we maybe look at some older application. Now, very often when we do programming at the company, right, a lot of times we go in and there are systems already written up, or systems that are maybe not very well designed. We need to like maintain it and kind of write it and redesign and rewrite it in a better way, something like that. And that's most of the time, right? And very few times can we go into a company and it's completely brand new project. We can design it, using the latest technology. So then that's more a reality thing in which we are all, most of us, and myself included. I was working for over 10 years at applications, in financial area especially, and manufacturing. So those are kind of really old system. And in fact, I was actually working on a Java messaging, JMS project too. And it was constantly, when you kind of doing the pops up thing, constantly some messages get dropped and all those things. So clearly JMS serves its time, right? So now it's like into new things, new way of doing things. So I like to just challenge us and say that while Reactive Streams has all these wonderful capabilities, can we make use of it and maybe help to transform some of these older applications? You can identify maybe data input and output. Can you make it asynchronous style of processing? And then basically, because of the flexible nature, you can have different libraries that implement this standard. You can actually build out a pipeline, data pipeline, that actually are implemented by different libraries for doing different things. Now, say, for example, here, Vertex is a very highly flexible library. I want to go into a bit more to, and also showing you some code and telling you some kind of a strong capability it has. So anyway, even Spring Reactor, RxJava, all these, they have a lot of operators and you can operate on the data. I wouldn't say one is better than the other. It's usually depending on your need and how much you are comfortable with the library too. That's also very important. And so you can kind of pick and choose. But again, I'll be sharing with you. And then these are ones, right? And I talk about these three and Akka. Then there's also microprofile too. Microprofile is a more microservices focused kind of used to be well Java EE, right now Jakarta EE. So microprofile works very well with the enterprise scenario, and it helps you with your microservices implementation. It's much lighter weight than Java Jakarta EE too. Well, I shouldn't say it's all kind of better, but I think Jakarta EE works kind of very well together with, say, microprofile. And then there's also RSocket, which Oleg from Kiev keep here in your country. And RSocket too is Reactive Socket, like I mentioned, that also supports like Reactive Streams. So now let me quickly go over Spring Reactor. There's the Reactor core. And basically in Spring, we know there's a Spring Web Flux, which is the web framework that leverages on the project Reactor from Pivotal or VMware now. So essentially too, they handles, we usually like work with Flux. Flux are like 0 to n, or many streams, or like mono, which is like 0 to 1 stream. So kind of like the highlight of it. And as such too, Spring It's essentially the same group of engineers that work on implementing Spring, and it started off since Java 8, and so the group of engineers also work on RX Java 2. So you can see that the operators, they're kind of similar. They kind of work interoperable. They're interoperable very much so. And then RX Java, as I just also mentioned, if you go to reactivex.io, you can find more information, and it's very popular with Android. And in fact, RX Java 1 used to be maybe like the primary reactive library that Android uses. But now with Android being Google announced basically using Kotlin, so now there's also RX Kotlin too that also supports the reactive streams as well. And so I already gave some examples. There are the observables from RX before RX Java 2, but RX Java 2 is flowables that has back pressure support in the V2. So otherwise too is observables. So, and then there's Vertex, and which I will spend a bit more time in a little bit that I can talk about too, but it's the Eclipse Foundation project. And by the way, all of these libraries are open source, so it's kind of very nice. You can kind of take it and start doing some work, and if you haven't already. So Vertex makes use of a vertical model, and it kind of helps with the deployment unit. So I'll show it the code to you. And Vertex is kind of strong because it's also the engine that powers Quarkus too. Quarkus is such as a newer Java cloud-ready framework. And is for you to help you develop your Java application. It's basically streamlined the whole building part too. So you realize that it is actually very fast. And today I won't have time to get into that, but I have a workshop which I just did. And actually we use a Tecton build lines pipeline to actually build and deploy to Kubernetes on OpenShift. So actually so that's something that verticals will kind of help, with the Vertex application. And Vertex also has its own runtime, and it has its own event bus too. So. Okay, and then Akka. Akka comes from Lightband, and I think Hugh McKee was also giving a talk, so I also would not be spending as much time, but they come from Lightband, and they support also Reactive Streams. But the thing is with Akka, it's actually very sophisticated if you haven't already worked with it. It actually has an API that's quite minimal and consistent too. And explicitness over magic, that's what they kind of call it, and compositionality, which is kind of like RX Java way of composition by composition. That's how you kind of, you do all the calls. And it actually has a flow, and essentially have a flow, and then it is processing, and then goes to a sync. It implements the Reactive Streams interface kind of underneath the hood, but when you use it, you're dealing with the flow and the processor, and then also then the sync, which collects all the data too. So again, handles back pressure, buffering, and all those things. And then there's also then a microprofile, which I also just now talk about. Its primary focus is on microservices. And I want to point out it's integrated with Open Liberty, which is an open source WebSphere product that actually heavily kind of maintained too by IBM, my colleagues too, over on the Open Liberty team. So. And also a quick thing too about microprofile, it also supports reactive messaging too. So just wanted to point out is that how it kind of communicates is using annotations. So any kind of method, you have a channel that you communicate with one another, and inter-methods communication through the channel, and they are all annotated. Basically, you signify what what the outgoing is and the incoming is, and that's essentially how you do and the messaging, and it supports reactive messaging too. So. And RSocket, as such too, is a binary protocol, and it's used for use on byte stream transports. It's a little bit kind of lower level kind of programming, and it has 4 models: request response, kind of 1-to-1, and then fire and forget, 1-to-0, and then request stream is 1-to-many. You can have one request and expecting many streams to come back. And channel is bidirectional, so you kind of maintain that channel. You have your requester, your sender, and receiver, but they kind of change roles, during the connection, and that's a channel that's kind of open, and state is being maintained. So quick slide to show you the RSocket. It's basically currently it's managed or kind of overseen by the members in the Reactive Foundation and open source kind of consortium underneath the Linux Foundation. And these are the 6 companies that started this effort. And one thing to point out is that RSocket is actually implemented by Facebook. Now, if you see all the feed that comes in underneath, is actually the implementation was done using RSocket. So just to give you an idea. And so without further ado, I won't say as much because I had a bit of a delay. So I want to make sure I kind of not wasting all my time. Now, one additional information is about OSGI. If you use the Eclipse editor, then you know that Eclipse editor is actually free, and maintained by the Eclipse Foundation. And so underneath too, the way Eclipse being implemented is using OSGI. This I forgot exactly, it's saying open source, some name of it. But essentially, it's a bit of an older framework, but it's actually a well thought out and well designed framework. And it's very modular. So the way it's doing things, it manages all of your packages very well. But anyway, I wanted to bring this up because OSGI doesn't have it explicitly say, support the Reactive Manifesto, but it has a push stream specification. So that's truly a push stream type of implementation too. So that's also one way of you can use, for doing streams. And the nice thing about this is that you can use the OSGI push stream not needing any dependency on other OSGI libraries, except for over here, OSGI promise. So basically, the push streams and the OSGI promise kind of work hand in hand. Now, I won't have time to get into all the details, but just wanted to point that out to you if you're interested. And it is not only an interface, it actually is a self-implementing API. So if you have that, it already implements the API for you that you can use directly. So quick kind of comparison, Reactive Streams in Java 9 and how it maps to push streams. So you can take a look. We talk about the 4 interfaces. That's how it kind of maps. And just wanted to point out is that on the connection kind of interface there, subscription, push stream, there's this auto-closable concept. So interestingly, in this push streams, it actually lets the client to your streams, you actually have access to close the stream itself. Now, in Reactive Streams, it doesn't have that capability on the library, on the consumer of the library side, so the library implementer. The subscription is basically managed by the library runtime. But the push streams too, you can do an auto-closable, so you can actually kind of have control over when to close the stream. So. Okay, so now let's kind of get into some use case. I hope I'm still having some time. I think it's probably, I know I had a bit of a delay start too, so please let me know. I think the staff, let me know if how much time I've left if I'm taking too much time. So, okay, so some Vertex example. Okay, I've been talking so much. I'm sure a lot of you are actually quite, let me quickly show too Vertex. I just thought it might be good too, in which, from current side. Okay, just let me quickly think. Why Vertex, right? I wanted to highlight that as kind of example code today because again, it's reactive, event-driven, very lightweight. I want to highlight the polyglot nature. You can actually, it doesn't dictate, and that's what I like about it too. It doesn't dictate how you should implement, but you can actually, have different, have your Vertex runtime call different libraries, modules too from within it. So I'll show you. And I have an example of how it calls like JavaScript or calling like Kotlin. I mean, those are still JVM, but you can have Python, Ruby, Go, and anything too. So, all right, quickly, let me then move. And I want to also bring up the word of Quarkus. Now, Quarkus, I like to also encourage you, if you haven't already done so, it's actually very highly efficient and it's making use of Vertex underneath the hood. And actually, not just Vertex, there's also a library called Mutiny too, which is also like developed and maintained by the Red Hat folks. So Red Hat actually invented the Quarkus, right? And we, IBM, to work with them too. And so the idea of the Quarkus is that it supports reactive and also imperative, all in the same runtime. So it's quite interesting. And if you get a hands on it, you'll realize that it is very fast. And I think I say, a lot of the credit goes to the use of the asynchronous capability and that's provided by the Vertex event bus. So this is how it works. Application, you usually you have different, like go into the routing layer. Then from there, it's basically is the Vertex that handles all of the routing. And Vertex has its own event bus. And so you have like requests going to Vertex and it handles it by Vertex. And it's highly reactive, asynchronous in nature. So, And you can visit more the vertex.io, and the Quarkus documentation will also talk a lot more in detail. And this is a polyglot use case of Vertex, which I'll quickly show you now. So I actually implemented a Vertex. Vertex has this model called, again, called Vertical. Vertical is a deployment unit. And so when you implement your code, it's actually not very complicated. And that's what I find it to be, very, very good to work with. And I also have a live coding stream in which I've been also demonstrating how to use it too. So over here, your Vertex, in the simplest case, your Vertex runtime is running in your JVM. And so over here, my example will be I have an API vertical. It's essentially a gateway. So there is handling all of the HTTP requests coming in, and it routes it accordingly. So then I route it to the different verticals that handle each job accordingly. So I have Java, Kotlin, and JavaScript kind of implementation. So I'll quickly show you there. And Vertex has an event bus. So the event bus too is nice because then it doesn't tie up the main event loop. It gets the request and then it goes around and does its job and tell whoever needs to do the job. So my main vertical can go on and do something else, not be held up by it. So that's the idea. And then for JavaScript, you might be wondering, how does it kind of communicate with the Java? Is that there's a sock.js bridge that's what I use. So, okay, so with that, then let me, that's right. So let me then quickly then get to showing you the code. Okay, all right. I've been, okay, sorry. Here, okay. So this would be my workshop that I just did, but I do want to quickly show you, and maybe I'll show, sorry. I have like multiple things. So, and here is just a basic, how do you implement a Vertex? So hello world, then in this case, will extend abstract vertical. So the vertical is the unit of deployment. So, and then it's actually the interface, this extend is an abstract class. So it's actually quite not that complicated. So if I kind of highlight this, you can see this is abstract vertical. I'm using the Vertex RX integrated library. Now Vertex also integrates very well with RX Java as well, because it leverages on the operator capability. It's very strong. And Vertex has this event bus. So they kind of both work hand in hand very nicely together. But so I implement that, and then that's all you will need is have you override the start, and then you do whatever you need to do. And in this case too, what I'm doing is I just create an HTTP server, and I'm using an RX Java 2 interface is basically the flowable. And over here, what I do is that I request flowable, and basically is taking my HTTP from the request stream. I basically converts it to a flowable. I can do that. And then over here, my flowable, I do a subscribe. So what I subscribe to is basically the request using a Lambda. And over here too is that in my request, I basically will send back, I subscribe to it, but I'm using a chain together my call, and I basically build up my return string, which is like hello world, and then whatever I get from the target environment variable in here. So that's just a very simple example. And then I listen, set the listener to 8080. And then in order to, this kind of like, let me kind of expand it a little. Oh no. Seems like my code kind of looks different. Okay, here we go. So in order to actually start up your Vertex, and this is the simplest way to do it. It can't get much simpler. It's basically start off your Vertex. You basically bring up the Vertex control center, and then all you need to do is deploy vertical, and that's how you can do it. So let's take a look right over here, hello world.class.name, or you can just simply do a new hello world. Will also do it too. And so you can see too, your vertical that you're trying to deploy will need to extend the abstract vertical, or you can write your own vertical too, and kind of like implement that or extend that too, and write your own as well. So, okay, so this is just a quick example, but let me also then show you. Okay, so this is that, and I will actually switch back to showing my. Sorry. Okay, now this one is the polyglot example. So I have the main class from the diagram there. I have the main class API vertical. So let me then quickly show you. So you can see too, like you can see, take a look at the whole list of imports that I have in here, but primarily too, I'm using the abstract vertical, and also too, I also have the router, which I'm like handling all the routing, the requests coming in. And okay, so then my vertical, I'll extend the abstract vertical. And then I also have some metrics that I'm measuring, how many times, it's being called and all those things. So you're seeing some of these. I'm using an atomic integer because it just handles the concurrency well. So I kind of make sure the data doesn't change, kind of more accurate. And so over here, so in my start, then I also make use of a, let me kind of do this. Okay, so I'm also getting properties. I basically using the Vertex as a config retriever. And over here, you can see it's a configuration retriever. So that's the nice thing is that I can read in all the properties from an external JSON file. And here's the JSON file. All it's doing a sample is just defining my port, my delay, kind of parameter and worker count in this case. So let's go back here. So I basically will retrieve all of my, my parameters, and I build it in memory, a JSON object. And essentially, too, my retriever, I can just do a .listen. So the listen will just listen for any changes. So if there are any changes, so basically I listen. If there are any other changes, I basically will read in whatever changes is in the configuration file, like, while in memory and load it, into my runtime without having to reboot and reset and restart my server. So that's a nice thing. And okay, so that's an example. And then there's also a stop that you can override to. So any kind of cleanup you need to do, you can specify it in here in the stop method. Now let's take a look then further. So, okay, so I'm dealing with this, but basically from the start to earlier in the start routine, if all goes well, then basically I will call the startup method. The startup method here too is that I'm doing a router, and I basically then binds it to the router binds it to my current Vertex. I create this router object. Then with this router, now anytime you do Vertex, you basically have to define handler to it. So in this case, I have a CORS handler that handles all of the, the cross object origin. If you're working with web programming, you're familiar with it. So you can actually build up a handler that handles the CORS too for your setting all the headers and dealing with permission and all those things. And then you can then do a mapping of here. I'm using this, kind of calling URL for health, then I basically call generate health and all these things. And then over here, as such, I'm still kind of in progress. I'm doing a Twitch stream. So this one I'd be kind of still working on, but there's a SOC JS bridge too that I can leverage on in order for it to be able to like talk with my JavaScript worker vertical. So that's what this thing is doing. So, okay. So over here too, this is the part then, that's when I start up if all goes well, right? All of this setup is all good. Then I go into creating my HTTP server. And so, and you can see too, again, I have a request handler. So over here too, I do a listen to the port. And basically this is where, I'm kind of got to this point. I know I'm listening, it's all good. Then I will deploy all of my worker verticals. So these are like the different methods that I define for deploying my Java worker, my JavaScript worker, and Kotlin worker in here. And over here too, I have my event bus too that I'm handling. My event bus, again, setting up the consumer handler to handle any messages that will be coming in and all that. So, okay, so here we go. Generate health. So you can see too, then these are like the different methods that handles what to do when a certain request come in, right? And so I think of interest would be here is that how do you actually deploy, your vertical? So as you can see, right, I call when it's ready, I have my HTTP listener, and I basically will invoke this deploy worker here. So all I'm doing in here is that I read in all of read in all the configuration parameters for my particular worker vertical, so it can get it. And basically over here too, there's deployment options that I set it up. That basically the Vertex, the control center, basically do a call to deploy vertical. Then you pass in the actual vertical class. In this case, API worker vertical is my Java implementation. Then you pass in all the worker options to it. And basically, then you also have the response, you define the response handler, what it does too. And over here too, for me, I'm just this deploy vertical here, I'm just keeping track, while I'm like, I deploy it, but I also set up some measurement to see how many times, this is being called and as such. So now that's an example of deploy Java worker. So likewise, if you do it in Kotlin, do it in Python, any implementation, all you would need to do is again have Vertex call deploy vertical, and then you pass in whatever that it's your worker vertical. So you can do it like that. And then basically for JavaScript, likewise, you say deploy vertical, then you pass in your JavaScript to be called. Now, of course, too, this is just a quick kind of introductory, but in reality, too, let's say I have this is how I organize my code. I have my main Java, and there's also main JS too. So JS is my worker vertical JavaScript here. But the thing is too, with JavaScript, as you know, we also have to do some work in the resources, web root, and you actually do need to include the Vertex event bus.js in there too. So, and then there are also another one too, in which I split it up. So then also another JavaScript that's kind of handling the actual event bus coming in and consuming all of these messages too. So that's with JavaScript. And then Kotlin is actually easier too, as we all know, is again just JavaScript, our JVM implementation. So this is the Kotlin implementation of handling requests in this case. So okay, so as you can see, like doing polyglot in Vertex is actually not a big headache at all, and it's quite direct and simple if you're handling some simple case, but of course it can get a bit more complicated. Now, the nice thing is with this event bus, it handles and deals with all the threads, so then you don't need to have to deal with it. So that's the idea. Okay, so that's that, and I will probably go back to my slide and see what my next thing is. So I kind of talk about that, and I think the Akka, I probably won't have time to go through with that. I was going to show that, and how much time do I have left, just so I know I have a little more time, or if I should show the deployment to the cloud, for example, can I kind of spend 5 more minutes or even less, maybe like...
Mary, hi, you have 2 minutes. Hi, you
2
have
minutes, okay.
2 minutes.
Okay, all right, then maybe I won't show, but the only one thing I can quickly show is that, and I like to let me kind of do this one thing first, because I know I got delayed earlier, so I think that I have something kind of this. So I like to kind of encourage you, if you want to get an IBM Cloud account, and then basically right now, by default, you can get a cluster, but it's only a one single worker pool. So it may not be able to do too much, but I would like to suggest that we also have our IBM Developer Ukraine or even every city. We run workshops that are OpenShift, and then if you get enroll, is all free, you can actually get like 48 hours of usage of a cluster. So that's kind of nice. So this is like, I define my cluster. The thing is, I won't have time to show is how do you actually do the part of how to deploy it, but maybe very, very quickly. I have done my workshop, so some serverless deployment. So all you would need to do, I quickly told you, if you're doing a Hello World, you do a Maven build, then all you need to do is you do need Docker, or if you want to have a separate Docker image, then you can skip the Docker build part. But the thing is, the very bare minimum, you can do a Docker build. And after you get your image build, you push the image to your Docker Hub. And then all you need to do is basically use an OpenShift and to apply the service YAML file. So service YAML file describe all of your build kind of deployment kind of definition. And in this case, I'm using Knative, which is a Knative serving to help you to deploy to Kubernetes. So, okay, so that's a quick thing. I just wanted to quickly show you before I get to the end part. So then you know that there was there to come, and also invite you to also watch for our, chances for you to sign up for a workshop. And I'm also doing a Knative Vertex microservices workshop. So if you're interested, let me know, and I can also send you the information or tell the organizers here, then you can join me too. So with that, I'd like to thank you all and thank you for your patience and allowing me to kind of go over time. And this is how you can stay in touch with me if you haven't already. But one thing I'd like to point out is that now I have my Discord server too. So if you want to continue the conversation, it's easy to find me on Discord because I'm always online there pretty much, and I'll chat with everybody. So this is how you can join my Discord over here. And these are my other ways of contacting me. And then there's the reactive systems information on developer.ibm.com. These are the reactive information that I talk about, and our IBM Java newsletter too. So, and yeah, and then with that, this is the IBM Cloud sign up. I will give the slide to your organizer too. So if you want to scan that, and you just need to give your ID, and then you can get a free usage of the IBM Cloud. I would like to suggest you to do that. These are the Reactive Streams resources. And my live coding stream on Twitch is Chicago time, so GMT. Actually, it's now winter time is -6. So every Wednesday I have this stream. I'm currently talking about reactive operators too. So, and also I'll be having a podcast. So I want to let you know. And then with that comes to an end. And thank you so much, and really appreciate this opportunity. Thank you, thank you, thank you. So yeah.
Mary, thank you very much for your talk. It was amazing.
Thank you. Thank you. Thank you so much. Yeah.
Yeah, next you will have a Q&A session. Please join by the link that you have in your email, and all the participants that were following your talk will also follow the link under the broadcast, and will follow you in the Q&A session chat. So thank you very much for joining Devoxx Ukraine this year, and we hope to see you next year offline.
I hope to come to Kyiv next year. Thank you so much. Yeah. Have a great day, everybody. Yeah. Okay. Bye-bye.